So today we have a 2016 Nissan Rogue all-wheel drive, and it has a noisy left front wheel bearing. So we're going to go ahead and change this. I found that wheel bearing was not available aftermarket, at least not in Canada, so I've had to get it from the dealer. So remove the wheel and the brake caliper assembly. Got the brake caliper off. A nice time to look at the brakes. I've ordered a set of brakes for this thing. You can see there's not much pad left there. So considering that we got it apart, we might as well do the brakes while we're here. There's the front rotor. It's pretty rusty. So we're going to put a set of pads and rotors in it as well. This is the hub and bearing assembly. It's bolted in from the back side. So we got to remove this castellated nut and disassemble it. So remove the cotter pin and castellated nut, and then the 32mm nut off the end of the axle shaft. Push the axle shaft in. Here is the new wheel bearing from Nissan, in case you're wondering, but check part numbers, but always. That's what it looks like. Now there is a magnetic reluctor built into this bearing, and in the back side and around here there's a wheel speed sensor, so we have to be conscious of that wheel speed sensor, that we don't damage it. Some of those sensors are over $500, so we're going to carefully remove the 4 bolts that hold the hub assembly in and try and drive pull a hub out without pulling the axle shaft off and actually damaging that wheel speed sensor. So these are the 4 bolts that hold the hub in from the back. Looks like they're 17 or 18 mil heads. And I mentioned that speed sensor is on this side. You can see it up there. So you have to be careful that when you're pulling the hub assembly out that you don't break that speed sensor. Don't even think about trying to remove that sensor from that cast knuckle, because it'll just bust off. So we carefully work around it. Hopefully we can get it out. So there's the wheel bearing assembly I was off. This is the speed sensor I was talking about here. You want to be careful to hold this axle shaft in while you're tapping on the bearing. Otherwise the flange on the CV shaft may break the plastic part of this speed sensor. And like I said, some of these speed sensors are over $500 for some stupid reason. We're going to clean up all the pieces now. Maybe give a little bit of paint to the backing plate and reassemble it. So I cleaned up the bore where the bearing goes in, cleaned up the bolts, put some never sees, cleaned the back of the backing plate, give a little shot of black paint on the back. I'll paint the front of it once the bearing's in. And we'll reinstall the bearing now. So here's a blown up picture of that hub and bearing assembly. The axle nut is 255 Newton meters, which is 188 foot-pounds according to a cross check. And the retaining bolt for the hub and bearing assembly is 88.3 Newton meters, which is roughly, what the heck did I say it was? 65 foot-pounds. So 188 for the outer axle nut. I'm going to wait till I have the rotor and brake caliper on so I don't have to turn this, and put a little Loctite on the nut. And the bolts in the back here, I think I said 69 foot-pounds, which I've already tightened. So, cleaning up the brake caliper brackets and replacing these stainless steel retaining clips. And this Nissan has some Rube Goldberg designed anti-friction springs in here that you better pay attention to which way they come off, because they're a little bit of a challenge to get back on. Just make sure you don't take them all off and throw them away before you figure it out. So when those clips are properly installed, they actually help pull the brake pads away from the rotor, I guess, to reduce drag. Engineers are always trying to glean that last little 1/16 of a mile per gallon. Maybe it helps. So I had run this Nissan on the hoist, and it generated a bunch of fault codes for the 4-wheel drive and the ABS and the traction control because the tires were spinning at different speeds. I was trying to isolate which corner the wheel bearing noise was coming from, because there was no play in the actual wheel bearing, and I could hear it with the stethoscope on the left front. So we're going to do a network scan and a network code clear. pick up when this is finished scanning. So I'm going to do a network code clear, key on, engine off. Not sure how fast it'll be. Usually the code clear is quicker than the code scan. So we've cleared codes out of 11 controllers. Hopefully there's no warning lights on. Now we'll take it for a road test.